going to do today is we're going to work on graphing quadratics. And we're just going to get a basis for them. Today we're not actually going to graph anything. So there's two different forms of a quadratic function. This first one, we're only going to do one thing with this today. We're only going to do one thing with this ever. What we're going to do mostly is graph quadratics in the form ax squared plus bx plus c, which we've seen that over and over. We saw it factoring, we saw it solving. So we're much more familiar with this form right here. So that's what we're going to primarily use. The first thing I want to talk about is what is the shape that the graph of a quadratic forms. So this is what it looks like if you were to graph either one of these equations. And another thing, if you have your notes, put some arrows on that graph. The particular image didn't come with arrows, but the arrows show that there are points beyond what we actually draw. And the shape is what we call a parabola. So the shape, that U shape, is called a parabola. Now there's two different ways that this graph can look for a quadratic. I have what I call my cereal bowl parabola, which is this guy right here. And then we also have what I call the rainbow parabola, which is when you flip it upside down. And we'll talk about both of those, their characteristics today. But when you go to graph a quadratic, when you go to graph a parabola, there's very specific points that we need. Because if you just pick any points, you might miss part of the picture. So when we graph quadratics, the specific points we need are first the y-intercept. So on our y-axis, where this parabola crosses, you will always have a y-intercept. There's always a y-intercept. It always runs into the y-axis somewhere. The x-intercept, so where you cross the x-axis here, you might have two, like this graph has two x-intercepts. You might have one, or you might not have any. So for the x-intercepts, you can have 2, 1, or none. And we'll see examples of all of those on Wednesday when we actually graph. But what we're going to spend an entire day talking about today is this point right here. This is called the vertex. That's the point at which our graph for a parabola that opens upward like this, the cereal bowl, that's the point at which it stops coming down, turns around, and starts going back up. The vertex on a parabola is always the maximum or minimum point. Again, it depends on which shape you have. We'll talk about that. That's a big part of your homework. Do you have a maximum or a minimum? It applies a lot to word problems, everything. So we're going to spend the entire day just finding vertex. So the other thing that's on this picture is this dotted line here. And since it's a dotted line, it's not really on our graph. But what this dotted line is called, it's called the axis of symmetry. And it always comes from the vertex. So the vertex is the point that kind of cuts our graph in half if we wanted to. And what the axis of symmetry does is if I had this on a piece of paper like you have, if I were to fold my paper on that dotted line, the two sides of the graph would line up because it's symmetrical around that line. So the axis of symmetry always comes out from the vertex and goes straight up. And what it does is when we get to graphing on Wednesday, it lets us find some points for free. So, for example, if you look at the x-intercepts from that dotted line, they're exactly the same distance. However many units this point is from the dotted line, this is the same. And what that does for us later is, since we only have one y-intercept, I'll be able to see how far is the y-intercept from that dotted line. And however far it is, if I go that many units in the other direction, I'll get another point for free. And we're going to, again, we'll use that on Wednesday when we actually get to graphing. It just lets us find more points because if this is 1 over to the left, this point's 1 over to the right. If this is 2 over to the left, this point's 2 over to the right. It's symmetrical about that line. We use that when we graph on Wednesday. So there's two things we're really talking about today. Shape, does it open upward or downward? And vertex, our maximum or minimum point. So if you look at these two pictures of the graphs, this quadratic, we say, opens upward. It makes this cereal bowl. And you can tell me whether or not a quadratic opens upward or downward just by looking at the function. And the way you tell is you look at a. If a is greater than 0, it opens upward. That's a fancy way of saying A is positive. So if you look at your ax squared plus bx plus c, if A is positive, it opens upward. We got a basic shape. For the open downward, my rainbow parabola, it opens downward if A is less than 0, which is a fancy way of saying A is negative. So just by looking at a function, you can say opens upward or downward by looking at the number in front of your x squared. Now the important part for today is the vertex. So on this first graph, the vertex is down here at the bottom. It's the point at which we change directions. So for this, we're going down, we come to the vertex, it's the bottom, we turn around and go back up. And for this particular graph, for every graph of a quadratic that opens upward, the vertex is a minimum. It's the very bottom of that graph. We don't go any further below that. And that ties in a lot with our application problems. The vertex is a minimum if your quadratic's opening upward. Now if I look at this other graph, this is still a parabola, this is still a quadratic, but now the vertex is up at the top here. Because it's where we were going up, 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 we stopped, changed directions, this time came back down. And for this particular graph, the vertex is a maximum. So your vertex on a quadratic is always the minimum or the maximum value. We either don't go lower or don't go higher than that. And we're going to talk just briefly about domain and range of these graphs. So there's a little recall. Domain is our span of x values. So we found domain several ways now. We found domain for sets of points. That was the first thing we did. Then we found domain for rationals. That's where we had the two sets and the u between them. Then in the last section, we found domain for square roots. We took the radicand. It had to be greater than or equal to 0. Then we set up the span. We're going to take domain again in logarithms, coming up in chapter 12. But this is looking at our graphs. We want to find the domain. So think about domain back from rationals. We always found the domain when there was a trouble spot. If we have a rational, it's a fraction. Where does my trouble spot in a fraction happen? What's the number one rule of this class? What don't we ever do? Divide by 0. So with rationals, we had a problem if we divided by 0. Well, if we go back and we're looking at this right here. Is there any chance for me to divide by 0 in this function? No, it's not a fraction. So we had some cases where we were looking at things and we're like, okay, well there's not a trouble area there. So no denominator, so I can't possibly divide by 0. So that was one thing we looked at when we considered domain. Do I have to cut any values out? Square root domain. We talked about you can't have radicands of square roots that are negative, but do I have a square root here? In my quadratic right here, do I have a square root? Square root. What's a square root look like? Square root looks like that. Do I have any of those? No, I have a squared. I don't have a square root. So if there are no trouble areas in my domain, so I can't divide by 0, I don't have any radical I have to worry about, how does anyone remember, using interval notation, how we would show a domain that has no trouble areas, that covers all of the numbers? So if we think, you say something? Well, what would your numbers be if you're using a... So let's think about it. Remember we did domain, we used to draw the picture? We did this for a couple of them. So if I have no trouble areas, I have no numbers I'm cutting out, or no number that I have to start at and be bigger than. Where is my domain going to run? Negative infinity to positive infinity. Nice thing about quadratics, every quadratic has a domain, negative infinity to positive infinity. Because there aren't any trouble areas. I can choose any value for x and plug it in and I'll get back a number. So for any of our quadratics, the domain is the same. The x values could be anything. There's no trouble areas. Now, what changes on every one of these is the range. The range is my y values. And the way you should think about finding your range is Let's say look down, then up. So for the range, we want to look down and find the smallest y value on the graph, and then we want to look up and find the largest y value on the graph. So if I'm looking at this first graph, I want to look down until I find the bottom. Well, we know the bottom is at the vertex. It's the minimum point on our graph. Range is y values. So where is this graph starting in terms of y values? -3. So I find the bottom of my graph and I see what's the y value at the bottom of my graph. The y value at the bottom of my graph is -3. So I'm going to start at -3. And how do I show that my graph actually reaches -3? When I go to write -3, what do I put around it to show I'm including it? What kind of brackets? Square brackets, yeah. Because we actually get to that point. That point's on our graph. It's at the bottom of our graph. -3. Now the next thing we want to do is we want to look on our y values and we want to try to find the top of our graph. So if I look and I'm trying to find the top of my graph, where's this graph going? Because I got the arrows. The arrows show that, yeah, this is all we drew for a picture. It's going on and on. It's going up to infinity. And parenthesis with our infinity. So the range is y values. If it opens upward, we know our vertex is a minimum, and we want the y value of our vertex. And it's going up to infinity. So for all of them that open upward, the upper range is always infinity. This always starts with whatever your vertex is. Whatever your vertex is. Domain on your next graph, still -infinity, +infinity. That will not change for quadratics. The thing that changes is the range. So whenever you're looking for the range, you want to look down for the bottom of your graph and then look up for the top of your graph. So if I look at this graph right here, where is the bottom of this graph going to be? -infinity. So the arrows show that this graph is going to keep going down and down and down beyond the picture that we drew. So this one's going to have a bottom at -infinity. Then the other thing we want to look for is the top. So I've gone down, down, down to -infinity. Now we want to see where the top is. So my top this time is at the vertex because of the way it opens. The vertex this time is the maximum, and range is always your y values. So my y value here is 1, and we include it, so we use a square bracket. So if you're ever asked for domain, I know there's a lot of these on your final review. If you're asked for domain of a quadratic, it's -infinity to +infinity every time. If you need the range, you've got to know which picture you have. If it opens upward, it starts at your vertex and goes up to infinity. If it opens downward, it starts at -infinity and gets up to your vertex. If you have a picture, it's very helpful for those two. Questions? So this is a little laundry list of the things that you need in order to graph quadratics. We're not actually graphing today. We're focusing solely on number 2, the vertex, and then we'll learn how to find intercepts on Wednesday. But the first thing that's good to know is what your graph is going to look like. Because when you find a bunch of points, if you know what shape they should connect to and they don't, something's wrong. So when you have a quadratic, we know we're getting either the U or the rainbow, depending on which way it opens. So I can look at these functions and say, just by looking at them, whether or not they open upward or downward. And it's all based on your value of A. Same A we use since factoring, ax squared plus bx plus c. So in this first example, what's the value of A? 2. So we know A is 2. If A is positive, then it opens upward. So if you look at A and A is a positive number, it opens upward. So we know that when we go to draw a picture of this graph, it should look something like that. And I know that my vertex on this picture would be a minimum. It's at the bottom of that. So in the second function, what is the value of a? Negative 1. It's the number in front of x squared. Same as when we factored, all the way back there. So if a is negative, that's how you know it opens downward. So our points should make something that looks like that. Our vertex would be the maximum, because now it's at the top. And then finally, for C, what's the value for A? 1. So this one opens upward, since A is positive. That's all you're going on. Is that number positive or negative? So it looks something like this, and our vertex is going to be the minimum point. So that's the first question I was asked. It's usually worth a point. Circle one, upward or downward. It's all just based on whether A is positive or negative. Questions? Now there's two different ways we find the vertex. The first way is what we're going to do 95% of the time. The second way I just show you in case you go on to 163 and you need to know it. So the first thing we're going to do is we're going to look at quadratics in that form ax squared plus bx plus c, and there's a formula. There is a formula that you need for the vertex. So the only other formula you've had to memorize so far is the quadratic formula, and this is actually just a variation of that. So your vertex formula, it's on number 2 here, is that x equals negative b over 2a, which is the quadratic formula if you just chop off the plus or minus square root business. Same thing. So what we want to do is find the coordinates of the vertex for the parabola, and does it have a maximum or minimum value? Does this function have a maximum or minimum value? So if I look at this first example, f of x equals x squared plus 6x plus 5. Is this parabola opening upward or is it opening downward? Upward. So we know this opens upward because a is 1, a is positive. So that means that in our minds, the general picture is something like that. It's our u. Upward is the u. So does this graph have a maximum value or a minimum value? Minimum. Right down here, the vertex is at the bottom. So I'm just going to say the vertex is a minimum. So that's part of the answer. Part of the question is maximum or minimum. In this case, it's a minimum just because it opens upward. Now we actually need to find that point. The vertex is a point, which means it has an x value and it has a y value. So the vertex is an ordered pair. So we need to do two things. We need to find x and then we need to find y. Well, x is a formula. X comes from the formula x equals negative b over 2a. So we just need to know what a and b are. We can substitute them in and simplify the fraction. So here I have a is 1, b is 6, and c is 5. Now we don't really need c, but we'll use it on Wednesday, so I just always go ABC. So substituting my values, very much like you do with your quadratic formula. So I have negative 6 over 2 times 1. I put parentheses around everything I substitute in. Which gives me negative 6 over 2 times 1 is 2. And negative 6 divided by 2 is negative 3. So that little formula there gives you the x value. So the x value here is negative 3. But now I need to find the y value that goes with negative 3. And there's not a formula you have to memorize for the y value. To find the y value, all you do is take this answer from the first part, plug it back into your function. So use a little formula for x, and then for y, you just substitute the value of x back into your function. So I'm going to use my function notation and say I'm looking for f of negative 3, which means just take negative 3, watch your parentheses, substitute it back in to your function. So whatever answer you get from the first part, you just plug it back into the function. That's going to tell you the y value. So if I work this out, I have negative 3 squared is 9. what are we at? Minus 18 plus 5. Negative 9 plus 5. Just a note. This came up a lot on, what was this on? Your test? This isn't, you can't do 18 plus 5 and then subtract the whole thing because there's not parentheses there. When you come down to all addition subtraction, you work left to right. So I had a lot of people who said, okay, 18 plus 5 is 23, 9 minus 23. You can't do that unless there are parentheses. So once you get down to just all adding and subtracting, just go left to right, and you won't mess up your signs. So you should get negative 4. And that's your y value. Whatever you get when you plug it back in is your y value. So my vertex, the point altogether, is negative 3, negative 4. So 2 parts. First use the formula for x, then you just plug it back in, and that's going to give you y. So for b, here's my function. Does this function have a maximum value or a minimum value? And base that question on, does it open upward or downward? So first, does it open upward or downward? Upward. So a is 1, so a is positive, which tells me it opens upward. Which, just like the u and upward, we've got the parabola that makes the u. So do I have a maximum or a minimum value? Minimum. So my vertex is down here. And there are questions on your homework that ask, they just start, do you have a maximum or minimum? It's all based on, does it open upward or downward? Is your vertex the top or the bottom? So vertex is, again, a minimum. If it opens upward, it's always a minimum. If it opens downward, it's always a maximum. And then the next thing we want to do is we actually want to find that point. So to find that point, there's 2 parts. First, x has a formula. X equals negative b over 2a. So if we get our ABC, a is 1, b is 9, and c is 18. So if I substitute in my numbers, I have negative 9 over 2 times 1. Now watch these negative signs. Just like with the quadratic formula, if b is negative, you do the minus and negative, which turns it back to positive. So I have negative 9, 2 times 1 is 2, so negative 9 divided by 2. Now when you're solving things, solving equations, I said to leave things as fractions. Because when you're solving, you want an exact answer. But when you're graphing, if I tell you to go to the x-axis and find me negative 9 halves, where are you going? Between what? Yeah, between 4 and 5. Why between 4 and 5, Robert? Because if you divide it. Yeah. If you want to find that, you need the decimal. You're going to find the decimal on a graph. You're not going to find 9 halves. So when you're graphing, when you're working with these, it's okay to use the decimals. When you graph, you use decimals because that's what you can graph. That's what we can conceptualize. I can conceptualize 4 and a half. It's hard. When you say graph 9 halves, the first thing I do in my head, divide it, get negative 4.5. So it's okay to use the decimals here. And then where do I find the y value? Substitute that value back into your function. So take your function and in place of x, use negative 4.5. So I'm going to have negative 4.5 squared plus 9 times negative 4.5 plus 18. I think it's 20.25 minus, oh yeah. And you can do that all at once in your calculator. I don't necessarily need to see your steps. Let's see what we got. Minus 40.5 plus 18, which is negative 2.25, I think. And again, once you get down to this step, just work left to right, or put it all in at once. So to write your vertex, it's a point, an ordered pair. So in an ordered pair, you put parentheses, your x value, comma, your y value. So the point is your vertex. We know that because this opens upward, that vertex is a minimum. Questions? So what we'll do different on Wednesday is we'll learn how to find intercepts and then we'll plot them. But we'll be doing this again all day Wednesday. Alright, so the last quadratic we want to find the vertex of in this format is negative x squared plus 2x. First of all, am I going to have a maximum or minimum? Maximum. How do I know I have a maximum? So a is negative 1. Which tells me that this parabola opens downward. So this makes the rainbow parabola. And the vertex, where it is, tells me whether or not the graph has a maximum or minimum. Vertex here is all the way at the top, which is the highest point. So I know that the vertex is a maximum. So that's the first thing we want to know. Max or min? Got to max this time. Second thing, we're going to use that little formula to find x, then substitute back in to find y. So I have a is negative 1, b is 2. So in my formula for the x coordinate, I have negative b over 2a is negative 2 over 2 times negative 1. It's negative 2 over negative 2, or positive 1. So that's the x half. I use that little formula, negative b over 2a, and that tells me the x half of my vertex. Now to find the y part, you just have to substitute that number back in your function. But you've got to be really careful here because of this negative x squared. When you go to substitute your number in for x, the number I'm substituting in is 1. So the number that goes in the parentheses is 1. That's the number I'm squaring. The negative sign is out front of that. And if you think back to 10.2, we did a lot of talking of the negative of something. This is the negative of x squared. So after I square my x value, which is 1, I just want to make it negative. Another way you can look at that, if you have a hard time with that, is look at this as negative 1x squared. So negative 1 times 1 squared. And then when you follow your order of operations, you do the squaring first, then you just multiply the answer by negative 1. So I find people usually don't have trouble if I put like negative 2 out front, but as soon as I just stick a negative sign there, it throws them off. You can also treat it as a negative 1. And then just plus 2 times 1. It's going to be 1 times the negative 1. It's negative 1. So negative 1 plus 2 gives me a y value of 1 as well. So my ordered pair here is 1, 1. So just be careful with that negative in front of x squared. If you need it, put it as a negative 1. So that's how we're going to be finding the vertex all day on Wednesday. This next little section is just, again, something I want to show you. So if you go to 163, you can say you've at least seen it before. This format here, you see you have a binomial squared. You may or may not have a coefficient out front, and this extra number tacked on at the end. This is another way to write a quadratic. And you can actually set these up from our problems if you complete the square. We're not going to do that, but it's where you might use completing the square. This format tells you the vertex like that. No work required at all. That's one of its big advantages. Disadvantages, trying to find your intercepts like on Wednesday become a little bit more difficult. So we're just going to find the vertex again just to talk about it. all you have to do is look at the number with x. That's the x value once you flip the sign. So if I'm going to write my vertex, if I look at the number with the x, it's -1, flip the sign, +1. It's the x value of the x coordinate of my vertex. The number that's on the end here is y. No change is necessary. So the vertex for this quadratic is just 1/6. But you can only do that if you have this format here. If you have ax squared plus bx plus c, you got to go through the formula and all that mess. But if you have your binomial squared, you can find your vertex just by looking at it. So for b, if I want my vertex and it's in this format where you've got that binomial squared, for the x value, look at the number with x, but flip the sign. So the x coordinate of my vertex is -3. That just has to do with the way that this is set up. The way this is set up, it gives you the vertex. The number on the end here, as is y. So you say you like these, but the problem then is that people get the two confused and try to look at this and say, oh, my vertex has got to be 2, and then I don't know where they get y from. But yeah, these ones are nice. The problem is, if you had to set this up, it's not so nice. Yeah. So for the last one, vertex, what's going to be the x coordinate of my vertex here? 1. Take this, flip the sign. And the y coordinate? -10. Last number as is. Again, they're really nice for the vertex, not so nice for the others. So we'll just stick with them for the vertex. Questions? Again, we don't do this a whole lot. You'll see this on your homework. That's about all we're going to do with that. It's the other one where you have that little formula, then you plug it back in. That's what we use all the time. And then the last thing we're going to do today, again, just focusing on the vertex. The vertex comes into our word problems. So there's a couple of things. We've had other word problems. We had work word problems. I don't know, we had some table word problems. We're going to have word problems in 7.8, variation problems. Those are fun, though. I really like those. So when to apply a vertex to a word problem. When you look at the word problem, the equation is quadratic, and you're asked for a maximum or minimum. That's the vertex. Quadratic's maximum or minimum is the vertex. So for this first problem, a ball is thrown upward with an initial speed of 32 feet per second. Then the height in feet after t seconds is given by the equation h of t equals -16t squared plus 32t. Find the maximum height of the ball. You will see these problems forever in your math classes because I'm going to illustrate. Here's a person. Here's the ball. When you throw something, it goes up and it comes down. Parabola. So if you ever take physics, you shoot all sorts of things out of cannons, whatever, they go up, they come down. You got lots of parabolas. So what I want to do is I want to know when is the ball at its maximum height. And what's the point up there? What's that called? Vertex. That's what we're doing today. So things to pick out, say if this was on your final exam, which there's typically one of these types of problems on your final, things to look at other than just the words. The equation is quadratic. You're asked for a maximum or minimum. When you're given a quadratic and asked for a maximum or minimum, or asked to maximize or minimize, it's always that point there, the vertex. Those are the things to look for. So what do I want to find? Well, let's get A and B and then just use our formula. It's not in the nifty format, so I can't just pull out my answer. So I have A is -16 and B is 32. Now, I'm not going to use x equals because x isn't my variable here. If you use x, it's not a big deal, but the variable that the problem's using is t. So I'm going to say t equals -b over 2a. and then substitute in my numbers. Negative 32 over 2 times negative 16. Negative 32 over negative 32, which works out to be a positive 1. Now, there's two things in these problems where you're throwing things. There's time and there's height. Is that my time or my height? Time. I mean, that's why they use T. So that's the time. That's the time that this is at the top. Is at 1, we're in seconds, 1 second. So 1 second the ball gets to its maximum height. What the question actually wants to know is, what is that height? And where do you think I'm going to find the height? Yeah. Take the time, substitute it back into the equation. So I have negative 16 times 1 squared plus 32 times 1. Order of operations say you've got to do the exponent first, that 1 squared. So I have negative 16 times 1. 32 times 1 is 32. Negative 16 plus 32 tells me the maximum height it ever gets to is 16 feet. A lot of times I have people read that problem, and after I tell them it's going 32 feet per second, after 1 second they say, oh, it's at 32 feet. That doesn't work because it's not traveling just straight up. It's got that curve to it, so it doesn't get all the way to 32 feet because as it goes up, it starts to come back down. So it's only getting to 16 feet. Questions? Expect to see this problem, again, not just in this class, but this type of problem. And they always start with negative 16t squared. The other numbers will change, but the negative 16t squared, look for it now. Like, look for it in your homework. It starts with negative 16t squared. It's throwing stuff. All right, here's our second problem. This is the one that used to be, the type that used to be on the final. They've changed it completely, so I have no idea what's coming. But a sub shop, at a sub shop, the profit P for selling X sandwiches is given by the equation. There's our profit equation. Find how many sandwiches need to be sold to maximize profits. So the things to look for is to see what type of equation do I have. It's a quadratic. And then the key word here is maximize. When I have a quadratic, where do I find the maximum? Vertex. Still the vertex. That's what we're doing today. Vertex. Maximum or minimum will be at your vertex. So I want to find the sandwiches. The problem tells me it's X sandwiches. So X stands for the number of sandwiches. So X equals negative B over 2A. And here we have A is negative 0.1, B is 16, and C is negative 2. So I have negative 16 over 2 times negative 0.1. In these word problems, make sure these answers are positive. I can't sell a negative number of sandwiches. So I have negative 16 divided by negative 0.2, which is 80 sandwiches. So if I want to sell, I want to maximize my profit, I have to sell 80 sandwiches. Now the second question is, how much is the maximum profit? So I want to know, what's the profit when I sell 80 sandwiches? How am I going to find my profit? Yeah, just plug it back in. If you have to do both questions, the second question is usually just substitute that first answer back in to your problem. So I have negative 0.1 times 80 squared plus 16 times 80 minus 2. Order of operations again, make sure you do the squared first. I have 6,400 times negative 0.1 plus 1280, I think. Yeah, 1280 minus 2 is negative 640 plus 1280 minus 2 gives me $638. So when I sell my 80 sandwiches, I'm making $638. It's my maximum profit. So for these word problems, because we have other types of word problems, If you see a quadratic and it's asking for a maximum or minimum, that is your vertex.